See here, one more important concept, normalization. Normalization. Check, listen carefully. See here, this first, this is given, SID determines yes name DOB. Understood? See here, SID is an attribute, yes name is an attribute, and DOB, date of birth, is an attribute. SID means student ID, it is an attribute. Yes name means student name, it is an attribute. And DOB means date of birth, it is also an attribute. These three attributes are in the student information table. There is a table named student information in which there are three attributes, SID, yes name, and DOB. And it is given that SID determines yes name DOB. This arrow is we speak this arrow as determines, means SID determines yes name DOB. This is a functional dependency. We will study functional dependency in the coming lectures. We will study functional dependency in detail in the coming lecture. What is functional dependency? What are the types of functional dependency? We will see here. Don't need to confuse here. Only listen what I am trying to say. Understood? SID determines yes name and DOB, where SID, yes name, and DOB are three attributes in the student information table. And see here, second, CID determines C name and instructor, where CID stands for course ID, C name stands for course name, and instructor is the, assume, writer of the course or instructor of the course. These three attributes are the attributes of the course table. And the third is SID CID determines fees, where SID is student ID, CID is course ID, and fees is fees, means, and these three attributes are the attributes in the mapping table. Understood? We will see what are these functional dependency and what is the meaning of functional dependency in the coming lecture. Understood? Only study the here what is normalization. See here, we have three tables, student information and course and mapping. Three tables are there, and these three tables are independent. Listen carefully. These three tables, student information, course, and mapping, these three tables are independent. And when we will store these three independent tables in one table, when we will store these three independent tables in one table which is named as R. See here, this is the table R. In the table R, I am storing three independent tables in the table R. See here, the student information and SID, yes name, DOB, SID, yes name, DOB, and course is CID, C name, instructor, CID, C name, instructor, and mapping is SID, CID, fees. SID CID fees means these three independent tables we are storing in the relation R. We are storing in the relation R, and in the relation R we have taken some data also, means student information, student S1, student name A, date of birth 1995, course ID C1, C name is course name database, instructor instructor is course, and fees is 4,000. Student ID is S2, student name is A, date of birth is 1995, is course ID is C1, course name is database, instructor is course, fees is 6,000. Understood? And student ID is S3, student name is B, date of birth is 1996, course ID is C1, course name is database DB, instructor is course, and fees is 6,000. Student ID is S3, student name is B, date of birth is 1996, course ID is C2, course name is operating system, instructor is Galvin, fees is 4,000. Student ID is S3, student name is B, date of birth is 1996, course ID is C3, course name is Elko, instructor is Goldman, fees is 5,000. Now see here, student S1 whose name is A, whose date of birth is 1995, is enrolled in the course C1, whose course name is database, whose instructor is course, and whose fees is 4,000. Student S2 whose name is A, whose date of birth is 1995, is enrolled in the course C1, whose course name is database, instructor is course, and whose fees is 6,000. Student S3 is whose name is B, whose date of birth is 1996, is enrolled in the course C1, whose course name is database, whose instructor is course, whose fees is 6,000. Same student S3 whose name is B, whose date of birth is 1996, is enrolled in the course C2, whose course name is operating system, whose instructor is Galvin, whose fees is 4,000. Same student S3 whose student name is B, whose date of birth is 1996, is enrolled in the course C3, whose course name is Elko, instructor is Coleman, and fees is 5,000. Understood? Now see here, these three students, S1, S2, and S3, these three students are enrolled in the same course. These three students, S1, S2, S3, are enrolled in the same course, C1, database, and course. See here, these three students are enrolled in the same course, C1, database, and instructor is course. And also see here, these three are the same student. S3 is enrolled in more than one course. The student S3 is enrolled in the course C1, whose name is database. Same student S3 is also enrolled in the course C2, which course name is operating system, and same student is also enrolled in the course C3, whose name is algorithm. So this is the same student. This is the same student. This is the same student. Same student is enrolled in more than one course, or same course is enrolled by more than one student. Same course, see here, same course is enrolled by more than one student, S1, S2, S3, or same student is enrolled in more than one course, C1, C2, C3. Understood? Now see here, in the relation R, we are storing one or more than one independent table. There are three independent table: student information, course, and mapping, and we are storing these three independent tables in the one table, due to which, see, listen carefully, when we are storing one or more than one independent table in one table, there is redundancy. Redundancy means repetition of data. Same data will repeat again and again. Redundancy means repetition of data. Same data will repeat again and again. See here, same same data is repeating 3 times. Same data is repeating 3 times. What is the reason of this repetition? This is called redundancy. Redundancy means repetition of data. Same data is repeating again and again. Same data is repeating 3 times. Same data is repeating 3 times. Why it is occurring? Because we are storing one or more than one independent table in the same table. See here, what is normalization? Used to reduce or eliminate redundancy in the database table. We use normalization to reduce or eliminate redundancy. This is redundancy. We use normalization to reduce or eliminate redundancy in the database relation. Redundancy can occur in the database relation if two or more independent relation is stored in single table. Means if two or more, here three independent table we are storing in one relation, in one table. So redundancy can occur in database relation if two or more independent relation is stored in single table. Here we are storing three independent table in a single table. So if we will store two or more independent table in a single table, then the redundancy can occur. Redundancy means repetition of data. Same data is repeating again and again. So we use normalization to reduce redundancy or to eliminate redundancy in the database relation. Understood? See, and see here SID in this table are SID CID together is the primary key. In this table are SID CID together is the primary key. SID CID together is the primary key. How it is together is the primary key, we will see in the coming lecture. How it is together is the primary key, which is key in the see here. SID determines yes name the author of birth, and CID determines C name instructor, and SID CID together determines fees. Means SID CID together can determine all attributes. See, if we see SID CID together, then SID, this SID will determine yes name date of birth, this CID will determine C name instructor, and this SID CID together will determine fees. Means SID CID together can determine all attributes of these three relation, of these three table. Means this SID CID together can determine all attributes of these three relations. These three relations so SID alone cannot determine all attributes of these three relations, and CID attribute alone cannot determine all attributes of these three relations, and but SID CID together can determine all attributes of the relation. That is why SID CID is the primary key in this relation R. We will see how I am saying that SID CID is the primary key in the coming lecture. Thank you.